Have you ever needed to turn a PDF floor plan, CAD drawing, or even an entire building into a detailed Revit model? If so, I've got something you might find really interesting. A solution that I'm working right now could be a game changer for you. Let me introduce you to the Point4Revit plugin. It's a powerful tool that accepts XYZ points from any external application or even device, and let Revit to generate model objects in real time using Revit SDK. In fact, it's fast, it's accurate, and super easy to use. So let's dive in and get started. Hey everyone, my name is Sergey, and I've been working as a software developer for the past 15 years, with a strong focus on Autodesk solutions. In today's video, I'm excited to share an interesting project I've been working on, and who knows, it might just spark some ideas or even help you out with your own projects. The core concept of this solution is to generate Revit elements directly from external XYZ points, wherever they come from, would it be any external application or even a device that can provide these coordinates. This is made possible through a Revit plugin that actively listens for changes in the XYZ coordinate source file. Based on the user's predefined configuration, it automatically creates the specified objects in real time. Essentially, it bridges the gap between external data sources and Revit, streamlining the process of turning raw coordinates into fully detailed Revit models. Let me show what I mean with an example. I've prepared two external solutions that provide XYZ coordinates. The first is a simple WPF application with manual coordinate input, and the second is an AutoCAD plugin that allows you to send picked points or selected curves. As I mentioned earlier, user configuration is the key for element creation. Right now there are three options available: wall creation, wall thickness definition, and family instance creation. Each option allows the user to set specific parameters for the creation process. For wall creation, we must specify the bottom level and top level, or height if the bottom and top levels are the same. Wall type props. Two XYZ points from an external application will define wall's position in the active view. For wall thickness, we need a wall type to copy from, and the thickness, which is calculated using three picked points. For family instance placement, we need the category, family type, and XYZ location point. Let's create walls using a WPF application. We'll leave the settings as they are, except for the wall type, which we will change to generic wall 200 mm. Next, we'll specify the wall points, and as a result, the walls will be created one at a time. For placing families, we need to define a category and select a specific family. In this case, we'll choose the column category and pick the first family available within this category. Then, using the WPF application, we'll specify an insertion point. Once that's done, you'll see the column being successfully created in the model. The WPF application here is designed to mimic the behavior of the hardware device, allowing us to create elements by defining insertion point using a laser pointer. This is actually part of what I'm currently working on, an Arduino-based distance measuring device. This device combines different sensors such as a gyroscope, ultrasonic sensor, and laser sensor to calculate the XYZ coordinate of the laser point. These coordinates are then sent to a source file that Revit plugin listens to in real time. Think of it's more like a targeted alternative to the laser scanner. Instead of scanning the entire room and generating a massive point cloud, this approach lets us focus on a specific objects we want to create. By simply pointing the laser at the key location, we can build a digital version of a building or apartment piece by piece. It's taken a bit of time to build the hardware device, so let's shift our focus to a second solution, recreating floor plans in Revit using AutoCAD. While this approach could work with any CAD application, I find it easier to create plugins in AutoCAD. For example, let's take this PDF floor plan. Normally, you'd insert the file into Revit and manually trace over the reference to draw walls. But with this solution, all you need to do is select curves or pick points, just like we did with the WPF application. As a first step, we'll use the PDF to AutoCAD command to import all the lines from the PDF into AutoCAD. This command is not standard AutoCAD feature, but rather an additional plugin I developed to convert PDF lines into AutoCAD or Revit compatible formats. Once the lines are imported, I'll scale them to align with the AutoCAD coordinate system. Depending on how the PDF was created, it might also be necessary to rotate or mirror the exported lines, a step that could potentially be automated in the future to further streamline the process. Once that's complete, we can specify the wall type with the new wall thickness value. To do this, we need to select the desired wall type. In my case, it's generic wall 200mm wall type, and use the Point4Revit wall thickness command to specify 3 points in AutoCAD. After that, the new wall type is created, and we can use it in the wall creation process. For the wall creation configuration, we'll use a newly created wall type. In AutoCAD, we can start recreating walls using Line4Revit command. When we select a curve, the CAD plugin analyzes the selected curve and sends all the vertices to the source file. The Revit plugin then receives these point values and creates a wall using all the vertex coordinates. It's quite similar to sending a single point, but instead of just one XYZ point, we are sending a set of points. This makes the wall creation process smoother and faster. But sometimes it makes more sense to use point picking. For example, if we'll have wall openings for doors, but don't need to create those cuts, we can use the Point4Revit command to simply pick points and create a solid wall instead. For furniture creation, we'll specify the furniture category and select the required family in the configuration window. In this specific example, we want to create table and chair families. Working with the families can be a bit tricky, since we need to understand how the family is structured and where its insertion point is located. In my case, I know the insertion point is at the center of the element, so I'll select the center of the table for placement and do the same for the chairs. The source of point can come from virtually any third-party software, such as the CAD application, external software, hardware device, or even a web-based application. For example, as a demonstration, I added integration with the Zycon web platform, which I'm currently working on as a part of my main job. Let me show what I mean. I've already brought this view and the families into Zycon application, and now I'm going to place instances on the reference plane. During this process, the web application notified the backend about changes in the database, and the Signaler service updates the local source file with XYZ coordinates and additional family instance information. This allows me to use that information to create objects in ActiveView, even without user configuration. As you can see, this tool is highly flexible and can easily be extended to create additional elements or incorporate specific functions and methods tailored to your own needs. If you're interested, you can find this solution in my GitHub repository and customize it to suit your own requirements, or try it out with prepared installation file. The link in the video description. If you have any comments, issues, or concerns, feel free to leave a comment or DM me. I hope you find it useful. Thank you for your time, and I'll see you in the next video. See ya!